I used to manage a team of 12 models. Do you know what my actual job title felt like? A full-time human search engine. I spent my entire day rolling my chair from desk to desk, answering the exact same question. How do I select all doors that have 60 minutes file rating? Where is my session box? I was spending so much time teaching software operation that I could not even get back to my desk to do my own work. If you lead a team, answering basic questions is drawing your productivity. If you're a junior modeler, waiting for your manager to be free is halting your progress. Hello everyone, I'm Clement. The BIM software I helped build just won a gold medal at a Geneva Invention Exhibition. And now, I want to teach you how to build yours. I'm here to show you that creating custom Revit and Navisworks tools with Python is actually fun and easy, even with zero coding experience. Watch this. I open the BIM Mentor window directly inside Revit. I type my question. How do I run an interference check between structural framing and duct? Now, this isn't standard AI. It does not guess. It doesn't hallucinate. It is strictly tied to an official documentation. If the answer isn't in the manual, it politely tells you so. But when it is, it replies instantly with the exact verified step you need. No more Chrome tab, no more outdated form. 1 hour of research or waiting for a manager, solved in 3 seconds. Context restore. Done. The tool on the left is my Pro version, built for corporate environment. But today, I'm going to teach you how to build a fundamental Python version yourself. The best part about this Python version, you can visit your own company-specific operation manual. You can literally clone your company BIM standard into an AI, creating a custom mentor for your specific workflow. It's incredibly powerful and perfect for learning the logic behind the magic. I've done the hard work for you. You don't need to type a single line. I've prepared the Google on my GitHub. Just download, copy, and paste. You have completed your own software before you even start. The code works perfectly, but if you're a BIM manager running a business, you may want a tool that acts as an instant mentor for the official Revit help documentation right out of the box. However, scraping and storing Autodesk's proprietary text is a massive copyright risk for business. That's why I engineered the pre-built Pro version with a zero copyright footprint architecture. It doesn't store a single copyright work on your hard drive. Instead, it uses a lightweight mathematical insight to instantly trigger a hidden live browser that reads the official website on the fly, summarize it, and give you the answer. It is safe, compliant, and requires zero manual setup. If you just want a done-for-you installer with a modern UI for your team, it is worth checking out the Pro version on my website. Even bits of support keep these channels alive. But if you want to understand how to build the custom database yourself, let's look behind the scene. For the part 1, the HTTP bridge and import, from line 1 to 50. Let's start with the foundation. When you are building AI tools inside Revit using PyRevit, you are usually running on IronPython. IronPython is fantastic because it talks directly to the Revit API, but it's at a massive weakness. It's discontinued from the modern web. If you try to use the standard Python request library to talk to OpenAI or Google, it will often crash. Furthermore, modern AI servers demand high security, specifically TLS 1.2. Older version of the .NET defaults the older security protocol. Look at line 16. Think of this line as a VIP club bouncer. Without this exact line of code, Google and OpenAI will look at your Revit plugin, see an outdated security patch, and instantly kick you out with a connection error. We are manually forcing Revit to use modern encryption. Next, look at the request wrapper class starting on line 18. Because we cannot easily install requests in a standard PyRevit environment, we are building a smuggler. We are creating a custom Python class that looks and acts exactly like the famous request library. But under the hood, it is securely using the native .NET web client. We give it a post method. We tell it how to handle header, how to encode JSON into UTF-8 byte, and how to catch HTTP error like 404 or 401. Finally, on line 55, we override the standard request name with our wrapper. Now, the rest of our code can be written in standard, beautiful Python and our smuggler handled the massive .NET translation in the background. For the block 2, the AI personnel and system POM from line 58 to 65. Here we define the system POM. If you just send a question to an AI, it will act like a generic chatbot. It may give you AutoCAD advice or write a poem. We need to give it a strict job description. We tell it, you are our expert Revit support assistant. We command it to Revit usage. But the most important part is the limitation guide rail on line 65. We explicitly tell the AI if the context does not contain the answer, politely say, I'm sorry. This prevents hallucination. In the professional BIM environment, a wrong answer is worse than no answer. If the AI does not know how your company names its parameter, we want it to admit ignorance, not invent a fake naming convention that ruins your model. For the block 3, the mess of the AI, the Cosine Similarity, from line 69 to 76. This is where the magic of the RAG, Retrieval-Augmented Generation, happen. Computer cannot read English. They only understand number. When we send text to an embedded API, it returns a vector, a massive list of 768 numbers. Think of this vector as GPS coordinates for concept. If I have a vector for how to draw a wall and a vector for creating wall geometry, those two GPS coordinates will be very close together in mathematical space, even though the work are different. The cosine similarity function is our distance calculator. It takes two vectors. It calculates the dot product and divides by their magnitude. A score of 1 means the text means the exact same thing. A score of 0 means that they are completely unrelated. We will use the math later to instantly find the right page in your company BIM manual. For the block 4, the RAG builder, indexing the knowledge base in the RAG builder code. Before our checkbox can search your given status, we have to build a database. We don't want to calculate vectors every single time a user asks a question. That would be incredibly slow and expensive. Instead, we want this separated builder once. Think of this script as a librarian. On line 52, it's open your human-readable Revit Operations Manual.json. On 59, it's look for every standard, every rules, and every tutorial you have written. On line 70, it's called a Gemini embedding API to get the GPS coordinates for that specific text. Finally, on line 83, it saves a new file, revitknowledge.json. This new file contains the title, the text, and the 768 number vector. Your library is fully indexed and ready for the AI to search at lightning speed. Block 5, the Switchboard, API caller at line 78 to 171. We don't want to be locked into just one AI provider. What if OpenAI goes down? What if your company banned cloud AI and mandated local model? We built a switchboard operator to handle it. Look at the Google Gemini. Google API requires a very specific nested JSON structure. Content, row, parts, text. We carefully construct this payload. We even add a fallback mechanism if the V1 endpoint returns a 404 error, meaning the model is too new for a stable release. Our code automatically rewrites the URL to use the V1 beta endpoint and try it again. Look at call local LLM at line 152. This is for Olama. Note that it doesn't use an API key for authorization. It just sends a request to the local space. This means the AI is running entirely on your computer GPU. No data leaves your machine. This is the ultimate solution for the strict NDA project. For block 6, the secret safe is the UI and local storage at line 175 to 280. When we initiate the Revit usage checkbox window, we don't want the user to type in their API key every single time they open the tool. But we also cannot hard-code the API key into the Python script. Because if you share the script with a colleague, you just leak your private key. Enter secret safe, the env file. On line 180, Load setting looks for a hidden env file in the same folder. If it's found it reads the text and split it by the equal sign and populates the UI text box. On line 185, on Save Config, does the reverse. When you click Save Setting, it writes your API key, your chosen model, and your knowledge base path in the local text file. This keeps your credential persistent, but safely stored on your local machine. For the box 7, the core logic, the detective investigation at line 229 to 301. This is the grand finale. When the user clicks Ask checkbox, the onAsk function trigger. This is our detective investigation. If the user has used RAG checked, we don't just blindly ask the AI. First, we take the user question and send it to the embedded API to get its vector. Then, we open our Revit-Knowledge.json database. On line 259, we run a loop. We compare the question vector against every single standard in your database using our Cosine Similarity mask. On line 262, we sort the result from the highest score to lowest, and we slide the list to grab only the top 3 most relevant page. If the score is about 0.6, we append it to our contact text. Phase 2 is the open book exam at line 275 to 278. Now we build a final system prompt. We take our original personnel and we inject the context test right into the prompt. We are essentially handling the AI and open book and say, answer the user's question, but only use the information written on those specific page. Phase 3 is the execution at 281 and 301. We update the UI to say thinking, so the user knows the tooth has not frozen. Then, based on the drop-down menu, our switchboard routes the augmented prompt and the user question to the correct AI. When the response comes back, we replace the thinking text with a final, highly accurate, company-specific answer. You have just built a fully functional, context-aware AI assistant directly inside Revit. With this tool, you can avoid repetitive tasks and start automating your workflow. No more manual clicking button. But I also know many of you are busy finding deadline, meeting client pressure, or debugging error just trying to set up automation. That's exactly why I created a pre-built version, a professional version of everything we built here. You can use it right away, with no manual setup, no code error, and no admin rights. An experience with this automation felt like when they run at full speed. It is not just a shortcut, it's a motivator. Once you have tasted what the supported version can do, you'll be inspired to learn how it works under the hood. For supporting me, you help me creating free, high-quality tutorial for everyone, while getting the polished, professional version for your daily work. You can join via my official website, links are in the description. Every bit of support keeps this channel alive, so together we can make Revit and visual automation easier, faster, and more accessible to everyone. Before you go, what's the next boring task you want to automate? Drop your idea in the comment. Your idea may become the next video. Let's be smarter, not harder. I'm Clement. See you in the next video.